All right, so last video here, logarithmic equations. So we did exponential equations in the last one. We're going to do logarithmic equations in this one. So first step on all of these is if you have natural log of a number or log of a number, you're going to solve for whatever variable you have and use your calculator. So in other words, if your variable is not inside the log, okay, so let me make that note here, variable not inside the log. So for example, if I have something like 2x natural log 4 equals 10. Well, my variable is not in my log, so I can solve this just like any other equation. Divide by 2 natural log 4, and x equals 10 over 2. I can simplify that, 5 over natural log 4. So if my variable is not inside my log, I don't need to worry about getting it out. The problem is if my variable is inside my log, I need to get it out of the log in order to get it by itself, in order to have it isolated. So what we have to do is solve for the log, then rewrite my expression as an exponential equation. Then I can solve for the variable, okay? And just like I said on exponential equations, a lot of teachers prefer exact answers, so just leave it like I would have with a log or a natural log in it. If you need a decimal or if you are able to use your calculator and get an approximation, again, 3 decimal places is what we prefer when we're doing logs, okay? So let's look at a couple of examples to start with. So natural log of 2x minus 1 equals 4. So my first step is to get this log by itself. So I'm going to add 1. Natural log of 2x equals 5. Then I take this and I convert it. So instead of natural log 2x equals 5, I'm going to put my base here, which in this case is e. And I'm going to write this e to the 5th equals 2x. So now I've taken what used to be inside a log, and now it's not inside of a log anymore. And then I solve for x, divide by 2. So as an exact answer, x would equal e to the 5th over 2. If you have a calculator and if you are going to write that as a decimal, you can take your calculator and just plug that into your calculator. E to the 5th and then divided by 2. All right, I'm going to leave it exact because that's the way I like them. All right, same thing on the next one. 5 plus 2 natural log x equals 4. The variable is inside the log, so I'm going to get that log by itself first. Four minus 5 is negative 1 divided by 2, so negative 1/2. Convert, so this is base e, so e to the negative 1/2 equals x. I don't really like that negative 1/2, okay? Depending on what your teacher wants you to have or feels about those negative exponents. We usually don't like those, so I would write this as 1 over e to the 1/2 or 1 over the square root of e. Any of those are acceptable. So notice in this case, the negative, you might think, wait a minute, can I have a negative? But we can because it's an exponent, and exponents can be negative. Okay. Let's try another one. So in this case, number 10 is like that first note that I made. Notice that my log doesn't have a variable inside of it, right? It's just, my variable's over here with the 5. So in order to get the x by itself, I just divide by 5. Log base 2 of 7 over 5. Now, we can't ever get that as a decimal, right? Because I can't do log base 2 in my calculator. So we could, and instead, let me go ahead and redo this problem again. If you need to get a decimal approximation for this problem, here's the way we would do that. I would actually start by rewriting this as an exponential equation. 2 to the 5x equals 7. You might be thinking, well, why would you want to do that? You just made it harder with the variable up in the exponent. But now this goes back to that exponential equation. If I want to get the exponent out, I can take the log of both sides and pull that 5x out in front. So 5x log 2 equals log 7. Then I can divide by 5 log 2, and x equals log 7 over 5 log 2. So then I could use my calculator and type in log 7, because it's a common log, base 10, divided by 5 log 2. And then I would have a decimal approximation if I needed it. Okay, so again, just kind of depends on what you need to have for what you are doing. All right, we'll do one more here. Number 11 here. 2 log base 3 of 5 equals x. And you might be thinking, well, I'm done. This is what x equals. But again, x equals that as an exact answer. Yeah, we're done. If I need to make it a decimal, if I need to make it something I can put into my calculator, again, I would do the same thing I just talked about. I'm going to divide by 2. I'm going to rewrite that as an exponential equation. 3 to the x over 2 power equals 5. Then I would take the log of both sides, or the natural log, either one. Remember, it doesn't matter. And I'm going to pull that x over 2 out in front. X over 2 log 3 equals log 5. Then I'm going to divide by log 3 and multiply times 2. So x would equal 2 log 5 over log 3. Now, if you start noticing some patterns in how these kind of work out, when I have log base 2 of 7, how that looks in the end, and log base 3 of 5, how that looks over here, we're going to come back to that a little bit later in this chapter about how we would simplify those a little differently than I do here. We're actually going to take a shortcut, but not until later. So if you find it, awesome. But we're not going to talk about it yet. So that's how we solve logarithmic equations. So these logarithmic equations, exponential equations, simplifying logs, we're going to use those for a lot of different applications and a lot of different things that we're going to do, especially like word problems and interest problems. So some of those problems are going to come back, and we're going to use logarithms to solve those types of equations. All right, and that's it. Short video here on logs. Hopefully you were able to follow along. And we will continue with our exploration of logs later on. All right, thanks guys.